Let's give thank you.
Yes.
Thank you.
Our next and final presentation
Thank you
is
for staying. I was afraid I was going to have like 3 people in the room.
our next and final presentation is from 22077 Marcus Minions, or Casey here, from Flower Mound, Texas. They'll be talking about using the Studica power module to simplify end effector wiring. Marcus Minions is a high school-based team from Flower Mound, Texas, and they have been competing for 3 years since 2022. Last season, they had a very impressive run, managed to advance to Worlds, competing at the Texas UIL State Championship and the first Texas Cowtown Invitational. Everyone, please welcome 22077 Marcus Minions.
I talked about it earlier. All right, so we're going to make your robots better. Okay. This is the last iteration of the Marcus Minions robots, and it looks kind of a lot like yours in that you got a big long slide, and then you got stuff out at the end that's got a twist and go up and down and do this, right? Okay. Common in robots. Reliability in robots is everything, says every coach ever. And even more so with the new way you advance, because if there's only 6 matches in your tournament or your qualifier and you're out of one of them, guess what? You're not on the first fix, right? And that counts for points now. So having a robot that performs every single time is a great thing to have, okay? Most FTC games require us to reach beyond the 18 inches, yes? Okay. Often you need servos or motors at the end of that reach. Okay. We have 4 at the end of this. Just pull that thing out and let it hang out there. Okay. Every servo you've got out there, if you're using regular servo wiring, is 3 wires. You got 4 servos out. There's 12 wires going out. They're being bent back and forth all the time, and they're little 22 gauge wire. It is something that is designed to fail. I'm going to show you how to reduce that problem, okay? So, we're going to do it with 5 things. We're going to show you, next slide. Well, we can go back up real quick. Wire management is generally the last thing a team thinks about, right? You CADed up your things. Are there any wires on any of your CAD diagrams? Okay. All right, let's go on to the next one. Next slide, please. All right, I'm going to show you how to replace the easy to separate connectors, okay, with ones that don't. We're going to eliminate all those servo extension cords. Anybody got these things on their thing that do that, right? And then, oh, our claw stopped working. We're getting rid of those, okay? We are going to reduce the number of wires to operate your servo, okay? We are going to increase the power of your servos. Who's ever wanted servos that are more powerful? Anybody by chance? Oh, okay. All right. We're going to allow those servos to continue to work even if it fails. Okay. And then I'm going to show you how to test stuff. Okay. Special thanks to Colin, who built this cool little demonstrator, which you are welcome to come down and take pictures of and rip off and store all kinds of stuff like that. All right, let me check my notes and see what all I have missed so far. All right, first up, replacing the easy to separate connectors. Consider your control hub for just a second. You're all familiar with the control hub. Every single connector on the face of the control hub is polarized and locks. Okay, you can only put those little, the red, white, and blue connectors in one way, right? Okay, and the red and black motor connectors snap in and they click, right? You got to push a little button. There's one other, and the XT30s we already knew was a nightmare. Okay, but the servos are not keyed, okay, and they don't lock in place. Why? Why they do it for everything else on the thing except for that? As they're old. These were developed in the 1960s for model airplanes, not robots, and yet we're using them for robots. Okay? So when you put them in a model airplane, because I'm that old, okay, these two, you lock a couple of these permanently in your airplane. The receiver would be like maybe this far away that's driving it, so you only needed a cord that was this short. And these never moved relative to the receiver, ever. And once you plug it in, you never ever mess with it. So and if you got it wrong, you always check your airplane ahead of time to make sure that the rudder worked. Okay? And then you forgot about it because you never took it apart. Okay? That's not a robot at all. That's not what we do with robots at all. The battery packs needed to be very lightweight in an airplane, so we used 4 NiCad batteries, 1.3 volts. And so the baseline power flow, this powerhouse of a motor, is only 4.8 volts. You can't run much of a motor on 4.8 volts. But it'll fly in an airplane because it's lightweight. Everything else on our motor, on our robots, is 12 volts. Lots more power, right? Okay. All right, in summary, these had to push a little tiny piece of balsa wood. And that balsa wood was pushing against air. And that was all we asked it to do. And that was the design of this. And that's why this is horrible. But we still recognize where they came from. Okay, at the end of this connector, you've got this thing and it's only, and the wires are only this long. So now you got to put an extender on it, right? Maybe 2 of them to get the thing to get it to go up and down the arm, because the wiring of this arm is really, really long. And then as soon as something goes wrong like that, they're not working. Okay? We're going to completely get rid of that, and we're going to first replace it with these cool little connectors here that are lightweight and they're long. Okay, and you can buy a whole jar of them on Amazon. And I encourage you to come down, take a picture how these ones are wired with regards to 5 volts ground and that. And then you can borrow ours, and it'll just plug in and it rocks, and it does not come apart. So that's the connection right at the end of the servo. Now locks and is positive and is polarized. You can't move it together. Who has ever checked? Oh, is the polarity of the control up good? Yeah. It's locked right at the servo, and somewhere in the middle of the extension cords, you twist it in the extension cord. Anybody ever done that? Come on, so true. All right. So, servo connectors, easy, 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 easy. All right. Reducing the extension cables. Stop using extension cables altogether. Go buy a piece of this big old long cable and make one cable that is long enough to run the entire extension length of your robot with no breaks. You cannot use regular, you cannot rip off cable out of your computer. It's not big enough. It has, according to FTC rules, it has to be 22 gauge wire, available on Amazon. Okay. Put a set of connectors on the end of it, which I'm going to show you how if we've got down here. We use the screw terminals for the non-motion part of it. And so now they're screwed in solid on this end, and they're on a locking connector on the other. Also, these connectors add resistance. Anytime you put a connector like this, you're adding resistance. Anytime you're adding resistance to that connector, you're dropping the voltage, which means you're making your weak motor even weaker. Okay. All right. Let's talk about the 3 wires in a servo. 5 volts, ground, and PWM are those circuits. Okay. The first 2 are used to power the motor. 5 volts and ground. That's your circuit, regular DC motor kind of thing, right? The PWM is just a little square wave that tells the servo where to be positioned. If you were to ask any electrical engineer and say, I've got this great idea. I want to, because if your wiring is 5 foot long, how long is your circuit? It's 10, right? Because the electricity has to go from the battery all the way out, and then it has to come back down. And so you're running through 10 feet. So you're an electrical engineer. I've got this idea. I want to run an electrical, resistive device like an electrical motor at the end on a 10-foot long circuit using only 5 volts and running it through 22 gauge wire. He would laugh you out. He would say, you'll be lucky to get 3 volts at the end of that. Your motor will work horribly. And yet we do it all the time because it's what we've got. Right? We're going to change all that. The PWM signal, so you're going to lose lots of current through that 5 volt and ground wire. Sort of. The PWM doesn't care. You can drop it to 3 volts and the servo will still hear the frequency. Does that make sense? You don't get power, through the PWM. You get timing through the PWM. So running PWM through a 22 gauge wire, 10 feet, not a problem. Power, absolutely a problem. Okay? And that is where this guy is going to change your life. And he's going to make life way, way better. Wouldn't it be cool if we could only send the PWM up and send power separately? And so what we do is we slice away out of every servo. So we got all the wires coming out of the control hub, right? 3 for each servo. We throw away 2 of them. The only thing we are sending up through 22 gauge wire is the PWM circuit, which means this little wire can carry and handle 6 servos at the end of it. One of these 6 servos. Wouldn't that be nice? Now you've got to pair it with some red power wire. This would be 16 gauge, silicone coated, nice floppy, dependable, doesn't break when you bend it near as fast as the other wire. And so what we do is over here, we've got the section that's mounted on the chassis of our robot. This doesn't move. Okay? We've got this section in the middle, and this thing's going rolling around and stuff like that. And then we've got this stuff out at the end of our arm here, okay? And this doesn't move. Everybody good? And then we send out, so this thing is mounted at the end of our arm, and we send out 12 volts to this thing. The Studica power module takes 12 volts in. So you run a 12 volt wire off. If it drops to 8, no problem. Because this takes care of taking that 12 volts and providing 6 volts to every single one of these circuits. Not 4.8, not 5, like the control hub. The control hub only provides 5. And then when you run it through 10 feet of wire, it's even less. This provides, so you're already at 20% more voltage with this than what's coming out of the control hub. Already. Then you shorten the wires and you even have more electricity available to your motor, the thing that's actually going to do the twisting. Servos are rated higher. The same servo will give you more pump at 4.8 volts, at 6 volts, than it will at 4.8. As a matter of fact, when they list all the to determine whether or not a servo is legal in FTC, the testing is at 6 volts. All right. So that's going to increase the speed and the power of the servos at the end of the arm. And you've gotten rid of all the connectors. Okay, all the connectors that are going to fall apart magically by themselves. Okay. We've reduced the wiring, and now I want to add one other thing that is super cool. Okay, cool. So here's how Studica works. You've got the inputs on your servo on the one side, okay? And the only thing we bring across is the output. And then the Studica brings in 12 volts from down here and provides 5 volts out here. And this is what's at the end of your arm, and the servo's happy. That works really well. Now, can we go to the next slide? Reliability. Consistency. Words you've heard like all day long today, right? There's 2 ways to get consistency and reliability. Okay? Reduce the mean time between failure, okay? Which is a good thing to do, make it stronger, make it better, okay? Or add redundancy. Now, networking people use redundancy stuff all the time. If you've got a network switch or something like that, and the power supply goes in it, off in it, okay? Guess what? Cisco has put a second power supply in that automatically takes over when this one fails. And nobody ever loses their ability to see cats on the internet. They know how to do it. And we've done the same thing. So you've got this wire. Doesn't take up much space. We're going to run 2 of them. And what happens is, here's my control hub side. Here's the part on the chassis that does not move. Here's the wiggle waggle in the middle. And here's the end at the end of the arm, right? First thing to do when a signal comes out of the control hub is we split it. And we run it down 2 separate sets. Okay, if you cut one, everything out here will still work. That's reliability. Because these things are going to fail. It's a little 24, it's a little 22 gauge wire. And when is it going to fail? At the end of your season, because you've been wiggling it all day. It's worked great all season. And then you get the championship and you haven't replaced it because it wasn't broken. Now it does. So we've got an example. I tried to explain it. It's tough to see. I write it all down here. It comes in, the signal comes out, and we send it to these green blocks. Okay? Where we split, we send it up through a pair of the cables, and it comes up here. In order to test this thing, all you do, and for this to work, you disconnect this, you unscrew the connections down here, and you put a voltometer on it here. Because how would you know that this breaks? Right? You can be broken and just keep going, right? So occasionally, as part of your, like the night before, you disconnect these, and you put a meter here and here, and the wire goes up, and it goes around, the electricity comes up and goes down, and you got to, yay! If either side fails, we're good. If it doesn't work, you center this one, you put a connection here and here, and you know whether it's this side or that side, and you know which cable to replace. There's connectors on the end of these, so you already have this cable already built. You just replace this cable and replace the colors for the color, and they screw in there using ferrules, and you screw it in, and you're done. Let's go to the next slide. I may have missed something. Oh, okay. So this is where I'm just showing how you test it. Electrically, you test it here, here, and optionally there. Next slide. Okay. Robots. So let's recap, right? Get rid of get rid of resistive connectors that fall apart. Okay. Send more power, more voltage means more power to your servos. Make it redundant so it doesn't die, and use one big old long cable so there's no connections. So that's a pretty quick summary. Thank you, Studica, for giving us this thing. okay? Because this thing takes 12 volts in, a signal here, and you can see over here where the stuff comes in from the Studica. We just wired one into each of them. There's just one going into each of them. So come on down and take a look. I think we're done. We got There's one more point. Could you use this wiring for sensors? Absolutely. I2C, which is what most sensors, if it's analog, digital, or I2C, Rev's cables are three wire cables. There are 4 wire cables of which it's using 3, right? Okay. But I2C is only a 2-wire protocol. And so you could grab 2 of these wires and send an I2 signal back to your control hub using the exact same cable. The last piece of warning, if in your box of parts you have the old, now discontinued, now no longer sold red version of this that is white, throw it away. Do not use it. Do not use the red version of this. You come up and ask me why later on, but control, I'll just say it this way. Control hubs are way more expensive than this $37 piece of equipment. Throw that white servo booster from red. If you don't have one, away. Okay? Done? Done. Yes. Questions from the interweb? None? They all left.
Well, Alexander asks, does the Studica servo hub work like a Rev servo hub?
The old Rev servo hub is discontinued, and I do not recommend using it. The new one, it does a whole lot more, and probably does. I have not checked it out, okay? And it's really designed more for the new control system that's coming out. So I can't answer affirmative yes, but I would guess so.
You don't have to make these connections yourself inside of them. They're not hard to use. You order these on Amazon. There's a crimping tool. I don't know how to make me, but you just get your rainbow wire, your 6-string rainbow wire you get on Amazon. You'll crimp it together with that tool, and it's these little
JSTSMs. So take a picture of this one right here, and there's your connection.
But you do have to make them yourself. Though. You can't buy them through mail. But I mean, you get the custom links, everything's nice and pretty. You don't have redundant wires hanging everywhere. And then you just need to rewire your servos. Like on these servos, I graded them because it gives us an extra tug on the end of the servo again. And then I can pull on these and make the jump.
Other things that you might not recognize here, if you don't recognize this is a Wago power connector for the 12-volt systems. The cool thing is even if I unplug this connection right here going into the control hub, this will continue to work. It's pretty darn cool. Yes, sir.
So you do absolutely love things in Microsoft 13 being used to one, and there's only 2 wires that runs down. How are we going to add that?
Yeah, I think it's powered by I2C. I think it's sending, so it's doing even better job of that than that. It's sending all, I think it's what is it, 8 servers or something like that. And it's digitizing them all up, sending them via I2C, and then breaking them out at the end. So the same concept, but the problem is if you're using this control level, we're using on this. The I2C part of that I think is really.
And can Aiden be like he's not coming up?
Me? Yeah.
No, not you.
That's what you guys are. So putting this out there, see what we're going to do about like. These don't weigh hard. And I think there's actually more in the case than there is.
Oh, that's true. Okay. Okay, that concludes our final presentation, but before everyone